Welcome to solverfy.
So here is our balanced equation for the reaction of aluminum hydroxide with sulfuric acid. So in the first part of this problem, we are asked that if zero point 0.5 mole of each reactant, that means zero point 0.5 mole of aluminum hydroxide and zero point 0.5 mole of sulfuric acid is provided, then which one is the limiting reactant? So the limiting reactant is the reactant that will be completely consumed. So here we can see from the balanced equation that 2 mole of aluminum hydroxide will react with 3 mole of H2SO4. That means zero point 0.5 mole of AlOH3 will react with 3 by 2 times 0.5 mole or equal to 0.750 mole H2SO4. That means if in a reaction mixture we have zero point 0.5 mole LOH3, we need 0.75 mole H2SO4. But we don't have 0.75 mole H2SO4, we have zero point 0.5 mole H2SO4. That means we have less amount of H2SO4 than we require. That means H2SO4, since its amount is uh, less than required, or the amount is which is present in the reaction is less than required, that means this zero point 0.5 mole H2SO4 will be completely consumed, and that's why H2SO4 is the limiting reactant here. Now we are asked how many moles of aluminum sulfate can form under this condition. So as we said that when calculating the product, we will always count on the limiting reactant. That means we will count on or the calculations will go on based on the limiting reactants. So from here we can see 3 mole of sulfuric acid, which is our limiting reactant, can produce 1 mole of aluminum sulfate. So we can write 3 mole H2SO4 will produce 1 mole of calcium sulfate of Al2SO4 3. Or not aluminum, so not calcium sulfate, it's aluminum sulfate, Al2SO4 3. That means if since you are provided zero point 0.5 mole of H2SO4, which is our limiting reactant, that means zero point 0.5 mole of H2SO4 will produce 1 over 3 times zero point 0.5 mole, or 0.167 mole Al2SO4 3. That means under the reaction condition, we will have 0.167 mole aluminum sulfate being produced. Now, in the third part of this problem, we have to find out how many moles of the excess reactant will remain in the reaction. So the excess reactant will be here is aluminum hydroxide. Since H2SO4 is our limiting reactant, and it will be completely consumed. Now, first we'll have to find out how many mole of aluminum hydroxide will react with zero point 0.5 mole of H2SO4. Then we can find out how many mole of aluminum hydroxide will remain in the reaction. So At first, 3 mole of H2SO4 will react with 1 mole of, or not, 2 mole of a- aluminum hydroxide. That means zero point 0.5 mole of H2SO4 will react with 2 over 3 times zero point 0.5 mole, or 0.33 mole aluminum hydroxide. That means this much mole of aluminum hydroxide will react with zero point 0.5 mole of H2SO4, which is provided. That means the mole of aluminum hydroxide which will remain will be, since you are provided with zero point 0.5 mole of aluminum hydroxide, that means the remaining amount will be zero point 0.5 mole minus 0.33 mole equal to 0.167 mole aluminum hydroxide. So this is the amount, or this is the number of moles of aluminum hydroxide which will remain after the completion of the reaction.